Hi, Assalamualaikum warahmatullahi wabarakatuh. Welcome to the last chapter of SMU 3013. And in this chapter, it is all about vectors. Okay, so the term vector is used by scientists to indicate a quantity such as velocity, acceleration, displacement, or force. So this quantity here has both the magnitude and direction. So on the other hand, we have the term scalar. So scalar is a quantity that only has magnitude. For example, speed, distance, time, and temperature. So it is important that you know the difference between vector and scalar. Now, a vector is often represented by an arrow. So it is also a direction line segment as given on this figure here. You can see those are all vectors. And the length of arrow represents the magnitude, and the arrow points represents its direction. So in this example here, you can see that vector A and B are not equal because they don't have the same magnitude. The magnitude is different because the length is different, although they have the same direction. In the second example here, vector A is not equal to vector B because they have different direction, although the magnitude is the same. And the last example here is an example where vector A is equal to vector B due to the fact that they have the same direction, and also that the length of the vector is also similar, so it indicates the same magnitude for vector A and vector B. Now, when you have a two-dimensional vector, it can be thought of as having an ordered pair of real numbers. So it can be mathematically symbolized as you bold the alphabet V. So V stands for vector. For example, you can actually use any alphabet that you fancy, but in this case we choose V to represent a vector, and you bold it to indicate that this is a vector, and it is represented using this notation A and B, and A and B here are known as the components of vector V. So the notation above is used to differentiate between vectors and points on a plane. So these are the points on a plane, but if I use this notation, then this represents a vector. So sometimes another symbol that is used is having an arrow on top of the alphabet instead of this one. So naturally, a three-dimensional vector can be thought of as having an ordered triple. So you have an extra component here, which is C. So we have A, B, and C. There are three components in this vector. So we call this a three-dimensional vector, and it can also be represented in a three-dimensional graph. Okay, given the initial point, so A is the point at coordinate x1, y1, and z1, and the terminal point, which is at this coordinate x2, y2, and z2. The vector V here is a vector with representation AB, as such can be represented using this formula here. So based on this, you just subtract the terminal point here, so x2 minus x1, x2 and x1, terminal point, initial point, and y2 with y1, and z2 minus z1. So by doing that, you will get the representation of vector AB. Okay, so now let's look at this very simple example. Find the vector represented by the directed line segment with initial point. This is the initial point, and the terminal point is this one. So the vector here is represented by from point A to B, and it can be represented by -2 minus 2. So -2 minus 2. Next we will have 1 minus -3. So that will be 1 plus 3. Next is 1 minus 4. And this can be simplified as -4, 4, and -3. So that's the answer to this very simple example on vector representation. So with that, thank you very much for watching, and I'll see you in the next video.